All right, example 1 and 2.4 is using the cosine law, as you might imagine. And right off the bat, it doesn't give us a diagram, which makes this harder. I think it is really important to just start. So many students will look at this and read it and struggle with it and never really start anything. You have to really just start drawing, because you get caught up in your own head and then you really just sit there for 5 minutes. So to make it simple, I'm going to make a triangle. And I'm not making a scale diagram, so this doesn't, I mean, the line's not perfect, or the angles might not be right, who knows, and that's okay. So it says the surveyor needs to find the length of a swampy area near Fishing Lake, Manitoba. She sets up her transit at point A. Well, we read left to right, so we'll make that point A. Then it says she measures the distance to one end of the swamp as 468.2, and the distance to the opposing end of the swamp as 692, and then the angle of sight between the two. Now, the idea with that transit is that she should be able to see both ends of the swamp, because if she knows the angle between them, then we can use the cosine to solve it. So to at least make my diagram make a little more sense of the question, I'm going to put a little wonderful artistic green swamp right there. And so what this surveyor has done is that she's measured the side to either end of the swamp. So I'm going to make this the 468.2. I'm going to make this other side the 692.6. Now, again, this isn't to scale, and that's fine. The math will solve it for us. And then the angle of the sight between the two ends of the swamp here is the 78.6 degrees. Now, if you're going to deal with the cosine law, if you have the option, label it as ABC, and it will make using your formula sheet easier. So because the transit is in the top left here, I'm just going to go clockwise around my triangle. And then just to make sure that we see that connection between the cosine law, I'm also going to label my sides as A, C, and B. Now, that labeling is very, very consistent with the sine law. The sides get the lowercase version of the angle that doesn't touch them or that is opposite to them in the triangle. All right, looking at this triangle, I can see that I need to solve for A squared, right? That's the length of the swampy area. So I'm going to say that A squared. Now, right away, as soon as you put a side on the left-hand side, square the other two on the right. And that's going to help dealing with this much, much easier as we go. So I'm immediately going to put B squared plus C squared. And then looking on my formula sheet, that means I need to also subtract 2 times B times C. And then finally, the cos of angle A. Now, normally when we solve for a squared variable, we have to worry about that positive and negative root. We are solving for physical dimensions or physical lengths, and those can't be negative. So certainly if I were to solve for A, it would be valid to say the positive negative root, but again, we know that A is a physical dimension, so we don't need to worry about that negative. And this is the formula that we get. I just square rooted both sides, canceling that exponent on the A. I'm going to put the numbers in. And it is really important that once you get to this point, you really just have to make sure that you're capable and trusting of how you're putting this into your calculator. So we're going to make sure we take a look at that. And I'm going to say that A is equal to the square root. And I hope I left myself enough room here. But side B was the 692.6. That's squared. Side C was the 468.2. That's squared. Minus 2 times our 692.6 times the 468.2 times the cos of 78.6. Just barely squeaked it in there. Now that's definitely, a lot of terms and a lot of stuff happening there, but it's really important that all we're doing at that step is substituting the values of everything but side A, basically. Okay, just setting up my calculator so we can type it in now. I think, again, sine law, cosine law, or any trigonometry that you do in 20-1, you really need to be pretty hyper aware of what mode your calculator is in. The nice TI-84s will show you that it's degree mode at the top there. But if you don't have that, you can check. Now that you know your special triangles, we know that the sine of 30 degrees is 0.5. If I was in radians, that would not be true. The sine of 30 radians is not 0.5. So that's a good way to check what mode you're in. All right, I've always, not recommended that students type this in all at once because you get a lot of brackets and it gets really complex. So typically what I'll tell students to do is I'll tell them to evaluate the inside of the square root first and then take the square root of that number at the end. And that has, I think, over the years helped avoid some calculator mistakes. So I am going to type in the inside of that radical, and then I'm going to hit enter. So we're going to find the value before we even think about actually taking that square root. And I get this. So the B squared, or 692 squared plus 468 squared minus 2 times the two sides. And then finally the cos of 78.6. Nothing's happening after this cosine, so you don't have to close the bracket, but it's not a bad habit. And then I'm going to hit enter. Now, really important, if you get a negative number here, you have put something in wrong. because we are taking the square root of this, and we hopefully remember from chapter 5, you can't take the square root of negative numbers. The easiest way to take the square root is probably to hit second square root and then second answer. And that tells your calculator to take the square root of the previous line's answer. In case you don't remember how to do it, we could also store this value as, I don't know, let's just say R for inside the root. And then even if I clear my calculator, I can now use that R as the number that was inside, and you'd have to keep storing as you do more and more questions. So now I'll just take the square root of R because I put it in. And what I get, oops, I didn't hit R, my bad. So that I put the square root of the bracket, which is not really a valid operation. So the square root of R, I get 755.456. Now, it's really important that when you do these questions, we're not going to make these unrealistic triangles. It should make a little bit of sense. And I feel like that's reasonable, that is close to the order of magnitude of the other two. So, well, it's in the same order of magnitude. It's pretty close to those other two sides. And a good way to kind of eyeball that is the larger that this side is, the larger that this angle would have to be. So there is kind of, maybe not those, checks and balances is probably not the right word, but there's often some little kind of extra information you can read into to get just a little bit of an idea as to whether or not your answer is accurate or reasonable, I suppose. All right, so that answer does go on forever, but I can just barely read it. It asks us to round to the nearest tenth of a meter. So I'm going to say 755.5 meters. Now, I don't want to belabor the point of how wonderful math is too much, but try to think about what this would look like without trigonometry. You would be wading through that swamp with a trundle wheel or something like that, which I'm sure for the mosquitoes alone would be pretty annoying.